Okay, so today I want to talk about the density lab. There are three parts to this lab. So the first two parts is where you're going to make measurements of mass and volume so that you can calculate the density of a liquid. And in part three, you're going to calculate the density of a metal, again in this case by making measurements of mass and volume of that metal. Now, one thing I want to highlight is that sig fig is especially important in this lab because you're going to be making measurements of both mass and volume, and you have to look carefully at the instruments or the glasswares that you're using to make those measurements so you can calculate your density with the correct number of sig fig. Alright, let's talk in a little bit more detail about part 1 or part A. The goal in this part is really to show that measurement errors play a role in the precision of densities that you can get at the end, okay? And we're going to do this by calculating the density of water. And of course, if you want to calculate density of anything, you're going to use the mass of that substance, in this case water, divided by the volume of the water. Now, the important thing about this part of the experiment is the volume of water that you're going to measure out is going to be done 3 different times using 3 different glasswares. So the first glassware you're going to use is a 100 milliliter graduated cylinder. Second one, you're going to measure it with 10 milliliter volumetric pipette, and third one, you're going to measure it with a 50 milliliter burette. Okay. Now you might ask, why do we use the 3 different glassware? And that's a reasonable question, right? Why don't we just use one of them? Well, remember what the goal of the experiment is, as I said just now, right? We want to see how the density value and the precision of the density is affected by the type of glassware that we use. So naturally, what we expect is that when I use a graduate cylinder, there's going to be a different number of significant figures that I can measure compared to when I use a volumetric pipette versus a 50 milliliter burette. And that's really what we want to see here. So we will see that the precision of our density value, which is again measured by the number of significant figures you have, will be different for the 3 different glasswares. So here I just want to show you the different glasswares that you use for part A, right? As I said earlier, the first one is going to be a 100 milliliter graduate cylinder, which you would already have in your locker. You're also going to use a 10 milliliter volumetric pipette, and that one is going to be something you have to check out from the stockroom. And you also have to check out the pipette bulb that comes with that pipette in order to be able to use the pipette. You might check out this bulb, or there are other bulbs that the stockroom might give you. And the last item that you're going to use to measure the volume is the 50 milliliter burette, and that's another item that you have to check out from the stockroom. I want to point out something unique about the volumetric pipette that's different from the other 2 volumetric devices. So in both the cylinder and the burette, you notice that there is a lot of marks indicating volumes, right? Whereas in the volumetric pipette, actually, if you can see through this, maybe this is a little hard to see, there's not any mark along the volumetric pipette. There's actually only one mark, and that mark is located right here. And that mark really corresponds to the 10 milliliter volumetric pipette. So it corresponds to 10 milliliter. So if you get your liquid up to this height, then that would correspond to 10 milliliter. Specifically in this case 10.00, because that's the precision that was given by the manufacturer of this volumetric pipette. Now, of course, for the graduate cylinder and the burette, you're going to have to make an estimate when you're making the measurement. And you want to look back to lecture where we discuss making measurements and how to make estimates, where you have to read all the certain digits plus one uncertain digit for your estimate. Just a quick review on that way of making measurement. In this case, we have a burette, and I know that is because I see that these numbers are increasing as I'm going down. Now remember, when you want to make this measurement, you have to look at the meniscus, and you have to decide, what do these little marks correspond to? Well, since we're going from 1 to 2, each one of these little marks, which is division by 10, must correspond to 0.1, 0.2, 0.3, and so on. So an increase of 0.1, okay? So if I walk down here from 1, 0.1, 0.2, 0.3, 0.4, I notice that my meniscus is about 0.4, okay? So then my certain digits are 1.4, and then now I have to add an estimate to that number. Here's where your judgment comes in. Some of you might think that this is exactly at that line, in which case you would just say 1.40, okay, where the 0 is your estimate. Some of you might think it's a little below the line, so you might say it's 1.42, and so 2 would be your estimate, okay? Either way, that will be your measurement. So for this particular volume, you're going to have 3 significant figures. So in this particular measurement, I decided that it's exactly on the line, so I'm going to write 1.40, okay? Now, just because it's on the line doesn't mean you can get rid of the 0. So make sure that you actually include that 0. So if you think it's exactly on the line, you would put your estimate to be 0. Another quick point to make here is the positioning of your eyes relative to the meniscus. Remember that you have to look at the meniscus directly at the same level. You don't want to look at it above the level of the meniscus or below the level of the meniscus, because that's going to give you an error associated with the position of your eye. So you want to make sure that you're looking at it straight on or on the same level.